In this recording, we are going to discuss number 6 in the Math 313 practice quiz. It reads, if the fourth term of a geometric sequence is 16 and the eighth term is 256, which term has a value of 2048? So this question concerns the topic of geometric sequence. Let us go to a document to see where we can get help for such a question. So for question number 6, we can go for assistance by using question number 22 on page 57 in the electronic whiteboard. So let's go to the electronic whiteboard on page 57, and we can see number 22, and it's quite similar to the question that we are dealing with number 6. It says if the second term of a geometric sequence is 12 and the fifth term is 324, which term has a value of 8,748? So here it talks about briefly about a geometric sequence or progression, sorry. A geometric progression, or GP, is a sequence where each new term is obtained by multiplying the preceding term by a constant number. So whereas arithmetic sequence, you have to be adding by a constant number, here for the geometric sequence, you have to be multiplying by a constant number. A geometric progression can be expressed as A for the first term, and then you multiply A by R to give you the second term. You multiply by R again, that will be AR squared, AR cubed, etc., etc. All right, where A denotes the first term and R is the common ratio. So arithmetic sequence has common difference, but geometric sequence has common ratio. Example, first term is A is equal to 5, for example, and you have a common ratio of 3. So you have to multiply it by 3 all the time. So you start with 5, and to get the second term, you say 5 times 3 is 15, and then you multiply by 15 by 5 to get 75, and so on and so forth. Okay, here is another example. It seems here the first term is 3, and the common ratio seems to be 5. So 3, 5 is 15, 15 by 5 is 75 by 5 is 375 by 5, 8,075, and so forth. Now, with regards to a geometric progression, you have certain formulas that you must use to solve questions that pertain to geometric progression. For example, the nth term, t sub n is equal to a times r raised to the power of n minus 1. So this is the formula to find the nth term. Now the formula to find the sum of the first n terms comes in two versions. First version is where you multiply a, and in a bracket you have r to the n minus 1, and below divided by r minus 1. Now r must not be equal to 1, and here now the modulus of r, meaning the absolute value of r, must be greater than 1. So it will be more convenient to apply this formula when r is greater than 1. But if r is less than 1, like a decimal 0.5, etc., it will be more convenient to use this version, where you can see it will be 1 minus r to the n, because r will be smaller than 1. So it will be, avoid the negative sign, you can use version. But either way, you will get the same answer. But just to avoid the negative, you can use this one when r is more than 1, and use this one when r is less than 1. And you have what you call the sum to infinity, and it can only be applied when r is less than 1, and it will be e over 1 minus r. So let's go back to the example to see how this question was done. So as you can see, the second term of a geometric sequence is 12. So this can be written whereby t is 12, the term is 12, n is 2. You don't know what is a and r. So you simply write a times r to the 2 minus 1 is equal to 12. Bear in mind that I'm using the nth term formula because the question never mentioned anything about sum. Okay, see the second term of a geometric sequence is 12. So t must be 12 and n is 2. And all you can have is a times r to the n minus 2 minus 1 equal to 12 because you don't know what is a and r. So a times r is equal to 12 because 2 minus 1 is 1. Now the next piece of the information is the fifth term is 324. So t is 324 and n is 5. So you have a times r to the 5 minus 1 is 324. A r to the 4 is equal to 324. Now you have two equations and you have two unknowns a and r. You can solve for a and r. Or you can divide the bigger formula by the smaller one, and that will cancel out a. A divided by a is 1, so a cancels out. 4 minus 1 is 3, so you have r to be 3. 324 divided by 12 is 27. And then to find r, you cube root r to the cube. To cancel out the cube, you cube root, which is raised to the power of third. And you have r to be 3. Now remember you want a also. So since you have r, you can get a. You can use the formula AR is equal to 12. Or you could have used the other one, but you have gotten the same answer. And then you divide by, well, you know A is 3. No, R is 3, sorry. So you multiply 3 by E to give you 3E is equal to 12. 12 divided by 3 is 4. That will give you E is equal to 4. So you have the formula now. T is equal to 4 times 3 raised to the n minus 1. Because remember, A is 4 and R is 3. T, and you know for sure T, that's the formula for T. T sub n, sorry, T sub n is equal to AR to the n minus 1. Now you know A is 4, R is 3. So you have 4 times 3 raised to the n minus 1. Now the question says that you want the n that will give you 8748. So T must be 8748. It says which term n has a value of 8748. So T must be 8748 and you're solving for R. We're solving for n, sorry. So here you have the formula 8748 is equal to 4 times 3 raised to the n minus 1. You divide by 4 to cancel out 4. And then you use the power rule, logarithm rule, to bring down the power. Once you're solving for power, you have to use the log. And you just find logs on both sides. Log of 2187 is equal to log 3 to the n minus 1. And this will allow the n minus 1 the whole, because here p is like n minus 1. So just as p went in front of the L, that whole n minus 1 will go in front of the L. And we end up with log 3. N minus 1 times log 3. And then you just find what is. You have to divide by log 3 on both sides to solve for n minus 1. You have log 2187 divided by log 3 is equal to n minus 1. And then now you cancel out the minus 1, you add 1 on both sides. So you have log 2187 divided by log 3 plus 1. That will give you n. N appears to be 8. Let us verify if this is true. So you have 2187 log divided by 3 log, and then you go to add 1, and that will give us 8. So this is correct to verify. So let's verify what was done for our own. So here we identify that we have to use two formulas here, the nth term formula for a geometric sequence and the power rule for log, because we want to solve for n. Now, the first information say the fourth term is 16. The fourth term is 16 and the eighth term is 256. So here she used the bigger one, the eighth term is 256, she used it first. A times r to the n minus 1, that's ar to the 8 minus 1, 8 minus 1 is 7 is equal to 256. A times r to the n minus 1, n is 4, 4 minus 1 is 3, ar to the 3 is equal to 16. And now what happens now? She seems that she divided the bigger one divided by the smaller one. The a cancels out. 7 minus 3 is 4. 256 divided by 16 is 16. We can verify that. 256 divided by 16 is actually 16 years. So you have ar to the 4 is equal to 16. So you have to cube root 16 to get r. Okay, that means raise up 16 to the 1 over 4. So 16 raised to a quarter and that will give us 2. So r is 2 here. R is 2, so we can solve for a. A, she used the smaller one, a raised to the a times 2 raised to the cube. Okay, is equal to 16. 2 to the cube is 8. 8a is equal to 16, so she divided by 8. And she ended up with a is equal to 2 also. 16 divided by 8 is 2. This is correct. So you know what is a, r now, and you know what is a. So now you have to find what term that will give you 2048. So you have 2048 is equal to 2 times 2 raised to the n minus 1. So she divided by 2 on both sides. She get 1024 is equal to n minus 1. She applied logs on both sides to bring down the n minus 1. And then she divided by, she used a base of 2. She can do that. You can use any base, base 10, base 2, base 5, it doesn't matter. Base 2, 10 is more convenient. And now she divided by log of 2 to cancel log of 2 and add 1. And she get 11. So let's verify that. I'm going to use log to the base of 10. So I'm going to find what is 1024 log divided by 2 log, and I'm going to add 1 and we get 11. So is the 11th term, that is 256. There it is, right there. So this is correct.